So let's talk about vulnerable software and network vectors. Now, a vulnerable software is one that contains a flaw in its code or design that can be exploited to circumvent access control or to crash the process. Now, due to the complexity of modern software that we get nowadays and the speed with which new versions must be released to the market, almost no software is free from vulnerabilities. There is typically this pressure from upper management in a company that makes software. Maybe they have like a target. They need to publish this new software by the end of Q2, Q3. So you have this pressure, you have this demand, and releasing the software in time to the market is typically more important. It's prioritized over this actual security of the software. And due to the fact that software we get nowadays is very, very complex, it's advanced, highly, advanced functions, things like that, it's so easy for this software to have vulnerabilities in them. So a large number of operating systems and applications run on a company's appliances, servers, clients, and cloud networks, which will then directly increase the potential of the attack surface. Now, this attack surface can be reduced by consolidating to fewer products, and of course by ensuring that the same version of a product is deployed across the organization. Now, we do have this concept of unsupported systems and applications. So an unsupported system is one whose vendor no longer develops updates or patches for it. Now, under ideal circumstances, an organization should not be having unsupported systems or applications. However, there are very peculiar and unique scenarios or circumstances where the company, maybe for a limited period of time, they have no choice but to keep using an unsupported system or application. So what they want to do in that kind of scenario is to simply try to isolate such systems from other systems. And the idea is to reduce the opportunities for a threat actor to access the vulnerable app and then run exploit code. So using isolation as a substitute for patch management is an example of a compensating control. So we're unable to patch the system because ideally you want to patch, you want to update, but because the patches or updates are no longer available, one thing we could do to compensate for this is by simply isolating that system. Now let's move on to the network vector. So an exploit technique for any given software vulnerability can be classed as either remote or local. Now remote simply means that the vulnerability can be exploited by sending code to the target over a network. Local, on the other hand, would mean that the exploit code must be executed from an authenticated session on the computer. It typically requires physical access to the computer. So an unsecure network is one that would lack the attributes of confidentiality, integrity, availability, CIA, while a secure network would use an access control framework and cryptographic solutions to identify, authenticate, authorize, and audit network users, hosts, and traffic. So let's talk about some specific threat vectors associated with unsecure networks. We do have about 7 of them. The first one here is direct access, right? So getting physical access to an unlocked workstation, stealing a PC, or maybe even using a boot disk to install malicious tools. This would be an example of direct access to a network. And then wired network. So here, a threat actor can attach an unauthorized device to a physical network port and will then be able to launch attacks such as your denial of service, or maybe even eavesdrop on the traffic going through the network. And then remote and wireless network, where the attacker would either obtain credentials for remote access or wireless connection to the network, or could even crack the security protocols used for authentication. We do have, of course, cloud access. Cloud being such a big deal nowadays. The attacker is likely to target the accounts used to develop services in the cloud or manage cloud systems. They may also try to attack the cloud service provider, the CSP, as a way of accessing the victim's system. And then, of course, through Bluetooth, a Bluetooth network, the third actor would exploit a vulnerability or misconfiguration to transmit a malicious file to a user's device over the Bluetooth Personal Area Wireless Networking Protocol, We have default credentials, the classic, where the attacker gains control of a network device or app because it's been left configured with the default password. And you'll be amazed at how prevalent and how common this issue actually is still till today, despite all the security awareness training and all that stuff. Open service port, the threat actor would be able to establish an unauthenticated connection to a logical TCP or UDP network port. And that's it for the network vectors. Thanks so much for watching the video. I will see you in the next class.